Lorenz found a set of 3 equations, a simplified version of equations used to model convection, with only 3 variables that change over time. Let's try graphing them in 3 dimensions on a modern computer. The location of the first point is arbitrary. With each point after that, the computer steps forward in time by calculating the position of the next point based on the position of the previous one. It seems to change direction at random, and it never arrives at the same point twice. If it did, that would be the beginning of a repeating pattern. This type of system is now known as a strange attractor, and this particular one is known as the Lorenz Attractor. Now, let's try drawing 100 points at random locations and applying the equations to each of them. At first, it looks pretty random, but soon a familiar form emerges. The trajectories that begin on the edges seem to speed off in random directions, but all those that begin within a certain space end up in the attractor. It might seem that the differences in their starting positions no longer matter, but once they reach the attractor, their trajectories diverge, each following its own path indefinitely and never crossing. So the small differences in their start positions lead to increasingly different futures.